All right, welcome to The Explainer. So look, we use numbers all the time, right? Every single day. But have you ever really stopped to think about where they actually came from? We're about to dive into their secret family history, and trust me, it's way more dramatic than you'd ever guess. Yeah, and believe it or not, it's not just about, counting stuff. The story of numbers is this epic tale of human ingenuity. I mean, every single new type of number we have was invented to solve a brand new, really tricky problem. So, okay, let's start right at the beginning.
We're literally going to build the entire number system from the ground up. And we're going to start with the simplest idea you can possibly imagine. So, to do this, picture two friends. Let's call them Ram and Sham. And they're just playing with some marbles. This super simple game, it's the perfect way to get how the very first numbers even came to exist.
So Ram asks Sham, "Hey, how many marbles you got?" And Sham counts them out. 1, 2, 3, 4. These are the natural numbers. They're exactly what they sound like. The numbers that just come naturally to us for counting. They were the very first ones we ever needed.
Okay, but then what happens when Ram wins all of Sham's marbles? Now Sham has, he has nothing. And for the very first time, humanity needed a number to represent nothing. I mean, the invention of zero was an absolute game changer. It's what makes our number system whole. See what they did there?
But the game's not over. Sham has 0 marbles, but he wants to keep playing. Ram, being a good friend, says, "Okay, I'll lend you one." So now Sham has a marble, right? But it's a borrowed marble. He's actually in debt. He's at -1. And bam, just like that, we get integers. They were literally born to solve the problem of debt.
All right, so think about where we are. All the numbers we have so far, the naturals, the wholes, the integers, they're all these separate, distinct units. But what happens when you try to, divide them?
Well, when early mathematicians started doing exactly that, dividing integers, like say 1 divided by 3, they stumbled upon a whole new universe of numbers. Numbers that live in the gaps between the integers. And these are our rational numbers, the world of ratios, and of course, fractions.
But here's where it gets really interesting. When you take these fractions and you turn them into decimals, a kind of hidden pattern pops up. It turns out they all behave in one of two very specific, very predictable ways.
Check this out. Every single rational number, when you write it as a decimal, does one of two things. One, it just ends. It terminates. Like 3 divided by 2 is 1.5. Clean, done. Or 2, it goes on forever, but in a repeating pattern. Like 2 divided by 3 is 0.66666, on and on. For a long, long time, mathematicians were like, okay, cool, this is everything. It's all so neat and tidy, right?
Yeah. Well, that neat and tidy world was about to get completely blown up. A new kind of number was discovered, one that absolutely refused to play by the rules.
So, let me introduce you to the rebels of the number world, the irrationals. Seriously, their discovery was so shocking, it was practically treated like a dangerous secret. There's this legend that the Greek mathematician who discovered them, Hippasus, was actually drowned at sea just for revealing they existed. And why? Because unlike our nice, predictable rationals, the decimals for these guys go on forever without ever repeating. No pattern, just chaos. They're totally unpredictable, and they just shattered the old way of thinking about numbers.
And this, of course, brings us to probably the most famous irrational number of them all, pi, which also happens to be at the center of a really common point of confusion.
Which leads to this fantastic question. If pi is irrational, this wild, non-repeating decimal, then why do we always use the fraction 22/7 for it? I mean, we just said fractions are rational, so how can they possibly be the same thing? Well, the simple answer is they're not. They aren't the same at all. 22/7 is just a really convenient approximation. It's a useful shortcut, for doing calculations, but it is not the true exact value of pi. And that difference is absolutely fundamental.
Just look at the decimals side by side. Pi on the left, 3.14159, and it just keeps going forever with no pattern in sight. It never, ever repeats. But now look at 22/7 on the right. It goes 3.142857, and then guess what? It repeats 142857 over and over again forever. That repeating block in numbers, that is the dead giveaway. It's the telltale sign that proves it's a rational number.
A very, very close approximation of pi for sure, but definitely not pi.
And so, here it is, the whole family tree of numbers. We started with something as simple as counting marbles, and we ended up building this beautiful, incredibly complex structure. A structure that holds everything, from the nice, orderly rational numbers all the way to those chaotic, once forbidden, irrational numbers.
Think about it. Every single step on this journey, from just counting marbles to trying to define pi, was all driven by one thing: a need to solve a new problem. Which kind of makes you wonder, right? What problems are out there today that might force us to discover entirely new kinds of numbers? Numbers we can't even begin to imagine yet. The story of numbers, it's never really finished. Thanks so much for joining me on this explainer.